Will AI ever be as intelligent as humans? The concept is called artificial general intelligence. And today we talk to Peter Voss, one of the people who invented this term. And we talk to him about how to construct an AGI and why those LLMs like ChatGPT and co, why they go totally in the wrong direction. So join us for another episode of The Beginner's Guide to AI. It's an interview session again, and this time it's really mind-blowing, so stay tuned. So today we have Peter Voss here. He's CEO and Chief Scientist of Aigo. But before I say too much about him, it's better to let him talk about it. So, Peter, welcome to the podcast.
Yes, well, thanks for having me.
So, let's talk about Aigo. What actually do? You have something with AGI, Artificial General Intelligence. Is it like this? And what actually, for the listeners, what is it? What do we talk about today?
Well, yes, quite a big topic, artificial general intelligence. So artificial general intelligence is really what the whole idea of AI was when the term AI was coined 69 years ago. So 69 years ago, some people got together and said, we think we can build machines that can think and learn and reason the way humans do. And that's how the field of AI started. And actually, they believed they could crack this in like 2 or 3 years, 69 years ago. Now, of course, it turned out to be a much, much, much harder problem. So what happened to the field of AI? It turned into the field of narrow AI. So instead of building machines that can think and learn and reason like humans in a general sense, people would pick one particular problem that requires human intelligence, like container optimization or medical diagnosis or playing chess. And then they would write a program to do this particular task that really requires human level intelligence. So it's not, and this is really important, it's not that the program itself had the intelligence to figure out how to solve the problem. It was the engineers that figured out how to write a program to solve the problem. So, the perfect example here is Deep Blue, IBM's chess world champion. That was the first piece of software that actually managed to beat the best chess player in the world. But that program that was written was just using very clever programs techniques to be able to play chess, and it couldn't even play checkers. If you changed any of the rules of the game, it couldn't cope with that. So it really didn't understand how to play chess or learn in the way a human does. So that the field of AI has really been in the mode of narrow AI, and even today, even with these very powerful, large language models like ChatGPT, called generative AI, very, very powerful, but they still are narrow AI. To get them to do anything particularly useful in a company like customer support, there's a lot of human intelligence, external intelligence, that has to go in and figure out how to do the prompting, how to ask the questions, how to train the system, how to set different parameters, and so on. So that's really the field of AI still has been and still is in actually operating as narrow AI. So in 2001, I got together with a few other people who felt we should go back to the original dream of AI, to build thinking machines.
Really?
And three of us that we felt that, hardware technology, computers had become powerful enough, and software technology, the tools have become much better, that we were ready to go back to this original dream and to figure out how to build thinking machines. And so three of us actually coined the term AGI, Artificial General Intelligence, to kind of distinguish it from what everybody else was doing. And that's really what AGI is, to have a system that can learn by itself how to play chess, but also how to play checkers and how to do container optimization. All the kinds of things that a smart human could learn, that the system could also equally learn. And that's really the quest I've been on for a long time now.
I see. In 2001, you sat together and invented the term that we all talk about today. Yeah, that's really 2001. Did I mean when did you start actually thinking about AI as a solution? How did you get into AI? Because at that time, 2001, it was a strange field, I would say.
Right, right. Well, I mean, it just wasn't as visible, and there wasn't as much money going into it. But certainly there were some reasonably large, even government projects, in AI, but narrow AI. So how I got to working in AGI is, I think, a combination of my background and interests. So I started out as an electronics engineer and started my own electronics company. So I have a good understanding of how computers work at the lowest level, from the engineering point of view. But then I fell in love with software and writing programs, and my company turned into a software company. And that company ended up being quite successful. We went from the garage to 400 people and did an IPO. So that was very exciting. But it's also that when I sold my shares in that company, I had enough money and time on my hands to say, what big project do I want to tackle? What is really interesting and exciting? And it was pretty obvious to me that software could be a lot more intelligent. I was very proud of the software we developed, but still, if the programmer didn't think of something, it would just crash or give an error message, So
Right.
it couldn't learn by itself. It didn't have common sense. So how can we write software? How can we build software that actually can learn, that does have common sense, that can reason properly, and so on? And that's what got me onto the field of trying to understand intelligence. So I actually took off 5 years just to study different aspects of intelligence. I really wanted to understand, what is intelligence, even from a philosophical point of view, epistemology, theory of knowledge. How do we know anything? What is reality? What is our relationship to? How can we be certain of things?
Right.
And what is free will? What is consciousness? Those kind of things related to how the mind works. I also studied cognitive psychology, how children learn, what IQ tests measure, how our intelligence is so much more powerful than animal. What's the difference between our intelligence and animal intelligence? I studied that. And then, of course, I studied the work that had already been done in the field of AI, went to dozens of conferences and read hundreds of articles and books. And so that 5-year period was really what gave me the understanding of what we really need is artificial general intelligence system that can learn, and how to go about that. So in 2001 is actually when I started my first AI company to turn my ideas into actual prototypes, to experiment around. And that's really when we started building AGI systems,
The interesting,
proto-IG,
yeah, okay.
the early experimentation. I mean,
I will ask you later. When
today
we are
we
there.
still do not have
Yeah.
human-level
Yeah.
AGI.
But the interesting thing is, I read on your website that there's like those LLM models we have now, those ChatGPTs and so, and you do things differently. And what I find interesting is you went into how the human mind works. And I think, is it something like you have to build like a model of the human mind for intelligence, or is it just like getting more data and can a model with more data get into more intelligent, or do you know? I mean, I think you propose that you say you have to go a different way than the models now. Um,
Yes, absolutely. So, large language models, ChatGPT, generative AI, that they're all really the same family. They really started with the idea that we have a lot of data, we have a lot of computing power. What can we do with that? Because, companies like Microsoft and Google and Amazon had a lot of data and a lot of computing power. And they figured out basically how they could do really interesting things like speech recognition or language translation and image recognition by using massive amounts of data. But really, that was what was driving it. It wasn't some kind of a theory of what does intelligence require or what makes human intelligence. It was purely, hey, we've got a lot of data, we've got a lot of compute. That's the hammer. We've got what nails can we find? So and because it was so successful, it just gathered more and more momentum. More and more money came in, and it did more and more amazing things. Like ChatGPT is really quite amazing, but there's also pretty much a consensus now, is this fairly recent, that these large language models, this approach, a big data approach, cannot actually get us to human-like intelligence. And in fact, I can quote one of the luminaries. He's the chief scientist, chief AI scientist at Meta at Facebook. His name is Jan LeCun. And he recently said, large language models are an off-ramp to AGI, a distraction, a dead end. So he put it very forcefully, and I would agree with that. And actually, other heads of AI companies have said the same, but they have to kind of balance their message, because when they're trying to raise money, they have to kind of say, well, we are on the road to AGI, but we're going to need some breakthroughs or stuff. Large language models are not going to get us there, but give us some more money because, we'll probably get closer or something. But they really don't have any idea of, they actually say we need some more technical breakthroughs. Now, the breakthrough, according to my understanding, the breakthrough really is they fundamentally need to start with the question of what is important in human intelligence, what makes human intelligence so powerful and special. And then you'll understand that they're very different things from big data. And I can give two examples here. One of them is, these large language models now cost hundreds of millions of dollars to build. They use 10, 20 trillion pieces of information to train them. There are massive amounts of data that gets number crunched millions of times, and that's why it takes months to build these models and costs hundreds of millions. In fact, projections are that in the future, these models could cost $100 billion. So you compare that to a human, our brain uses 20 watts, not 20 gigawatts. We don't need a nuclear power station to, power our learning. And a child can learn language and can learn reasoning with maybe 2 million words, a few million words, 1 or 2 or 3 million words, not 10 trillion or 20 trillion. So there's something fundamentally wrong with that approach. And another key thing one can see is that these large language models cannot learn incrementally. Now, that's kind of a dirty little or secret or dirty big secret that people are kind of ignoring, because what happens now is when you collect all of this data to train it, it takes a few months to build the model, could be half a year even. It takes a long time to build the model. It cannot absorb any new information. It's basically from when you start your training to the end. You can see how absurd that is to have an intelligence system that cannot update its model in real time.
Yep.
So, I mean, for example, we're going to have election here in a few weeks, 2 weeks. We're going to have the election results. And then a whole lot of things will change, obviously based on whoever wins. If you now start training a model, say, a few days after the election, it'll take a few months before you have a model that includes that information. That's not a very intelligent, So so clearly one of the key aspects of intelligent systems is that they can learn interactively. Like we're having this discussion, I'm learning from you new things, you're learning from me, and that updates our model, so to speak,
Yeah.
of our understanding. So that's really what is required. That approach to AI is called cognitive AI. So it starts off with understanding intelligence, understanding cognition, as opposed to statistical or big data
Mhm.
AI.
You have actually a model like INSA was the model I found there. How do you do that in your firm? I think you try to do a different approach. You go a different way, or
Yes. So our approach, we call it INSA, um, and that stands for Integrated Neuro-Symbolic Architecture. Uh, but it is a cognitive AI approach. It's basically exactly a system that can learn incrementally. Now, the reason we call it a neurosymbolic is there's there are strengths and weaknesses in the original approaches to AI that were symbolic mainly. Now, symbolic is basically more a mathematical, logic-based approach where you have a lot of logic statements. It doesn't use big data, but it uses a lot of rules. So they're kind of rule-based systems. Now, rule-based systems are very good at logical thinking, formal logical thinking. Now, the problem they have is in the past, and why they never really took off very much in the 70s, 80s, and 90s, was that they're very brittle. When you design a system like that with rules, the rules tend to be binary. It's either true or false. And if it gets one of the rules wrong,
okay.
then the whole system breaks down.
Mhm.
So you really need more of a sort of fuzzy, intuitive
Yeah.
matching. So the early AI was all symbolic. The current AI, the big data approaches, they are neural networks that inherently have more fuzzy pattern matching type of operation. So they don't have that kind of brittleness. But on the other hand, they are not good at logical thinking,
Yeah.
consistent
Yeah.
logical
Yeah.
thinking. So there are quite a few people who say what we need is we need the benefits of both neuro and symbolic approaches to AI. So if we can somehow combine the two methodologies, now there's a bit more to it, and the fact we call it integrated, you can't just take a symbolic AI system and a neural-based system and somehow glue them together. They really have to be integrated, that sometimes they operate in neuro mode and sometimes in symbolic mode. So the two modalities of whether you are pattern matching or whether you are thinking logically need to interact
Mhm.
very closely with each other. And that's what our design does, is basically we have a high degree of integration between the neuro aspects of our system and the symbolic aspects of our system. It's really one system that can operate in both modes. But it's
True.
the basic design and the basic approach is basically a cognitive AI approach of what is important in human intelligence. And it's basically pattern matching and concept formation, that we as humans can form concepts and abstract concepts, concepts of concepts of concepts.
Mm.
And we also have metacognition. We can think about our own thinking. So these are some of the components that you have to have to get to AGI.
Okay. Yeah. This is like interesting is that you have different models that work together, and that there whether this decision which model takes over what, and um
Yeah,
is it like
it's not really quite like that. It's not. You see, everybody thinks in terms of models
Mhm.
but models are these pre-trained things, and uh, you know. Uh, Now, we also talk as humans, we have like a model of the world, or a model of something, which is basically our understanding of it. So in the cognitive architecture, it's not that you have a bunch of different models that you're switching between. it is really like our own brains. Everything is fully integrated. So calling it a model is a bit confusing because it's not a model
Yeah.
in the conventional sense. It's a network of all the knowledge and skills that you have.
It's good that I made that mistake, because that was a good clarification. Yeah.
Yeah, I mean that it's a very common way to think about it, is that people think that cognitive AI is just lots of different models that you train and they somehow no, they would still have the same problem of not being able to learn incrementally. So you really they're not the model in a cognitive AI system is completely different from the models in pre-trained. GPT actually, the word already tells you quite a bit. G means generative. It makes up stuff. And that's, hallucinations. It makes up stuff because it's trained on 20 trillion pieces of information, good, bad, and ugly. And the system, it gets stuff from all over the internet and wherever they can find data. And the system doesn't know which of the data is good and which is bad and which is ugly. So GPT, G is generative, it makes up stuff. And P means pre-trained. It's trained at the factory, and it basically cannot learn once you start using it. And then the T stands for the particular architecture that is kind of a breakthrough innovation of about 6-7 years ago, called transformers. T for transformers. And the transformer technology is really helped to make these systems much, much more powerful, but it also commits you to pre-training the system. So using transformers, you have to pre-train the system. You have to train it in bulk. Using transformers means you cannot learn incrementally in real time.
That actually, the point is, I mean, I think one of the most important things of intelligence, of human intelligence, is to learn. And if a model is pre-trained, that says everything about the model. It's not, in a sense, able to learn. It's not, in a sense, intelligent. Yeah. But I want to go back a little bit more in the thing of the realm. What can I do then with it? I mean, ChatGPT people use, but what's the advantage of using an AGI then? I mean, you have the idea to use general intelligence. What's the advantage?
Well, I mean, you could first of all look at what is the disadvantage or what are the limitations of large language models. First of all, you can't take a large language model, for example, and put it into your company as like hiring an employee, because it couldn't learn by itself. I mean, I don't know what employees you hire, for your business, but if you want to hire, you can't take ChatGPT and just say, okay, do this job, and do that job and learn this job, So they because they cannot learn by themselves autonomously, and AGIs by definition will be able to do that. It really makes it fundamentally very, very different. The second thing is, of course, what we spoke about is the enormous cost of building these systems. So if you want a custom system, that is, say, customized to medical research or something, you have to train this model for one particular area that you want to research, and then train another model for something else. But really, the Achilles heel is their inability to learn incrementally. That's sort of the one thing. The fact that they hallucinate and you can't trust them is another problem. But the biggest one is that let me sketch out what AGI will be able to do, because it is really, really profound. And a lot of people who've thought about this deeply make statements that I would agree with, that AGI will be bigger than the internet. It'll be bigger than electricity. It'll be the most impactful invention, innovation ever that we've had. So let me give 3 examples of what AGI will be able to do. One of them, imagine you have an AGI that is, say, trained up to a college graduate level, just general knowledge, college courses. That AGI could now train itself to, for example, become a cancer researcher, a PhD level cancer researcher. And I say train itself, because like a human at that level, you can hit the books, you can learn. You can ask questions, you can ask help from people or whatever, but largely it can be self-motivated to become a cancer researcher. Now you have one PhD level cancer researcher as an AGI. You can now make 1 million copies of that. So you now have 1 million PhD level cancer researchers that can chip away at the problem, pursuing different avenues, studying different papers, but also sharing the information that they gather, without the ego getting in the way, and they can share information much more easily, and reason much better than humans can. So the tremendous progress we'll make in, cancer and other diseases, by just unleashing this incredible power, intellectual power, will be tremendous. But not just in diseases. You take battery technology, for example. Nanotechnology of having little robots that can go through our bloodstream and repair things. Pollution. All the problems that basically where we need better research. Getting a fusion to work, getting quantum computers to work, and we'll make so much more progress in those areas. So that's one realm, is basically in research and technological development. The second area that is sort of very obvious is any desk-bound, cognitive desk-bound job can be replaced with AGI. So we'll dramatically reduce the cost of goods and services. Whether it's accounting or programming or customer support or whatever it might be, administration, they can be done at a much, much lower cost. And that'll create radical abundance, basically, because there'll be more things available at a much lower cost. So that's the second, that's kind of a very obvious one. The third one, though, I think is really, really profound, and that is what I call a personal assistant. And the reason I double up on the word personal is, to me, the vision is to have AGI, that each person in the world will have their own personal AGI. And the first sense of personal is that you own it and it serves your purpose, not some mega corporation's purpose. Not like what we have now, Siri and Alexa and so on. That it really is yours. You control your privacy, what it shares with whom, and it's yours. You control it. The second personal is the hyper personalization. It'll get to know you really well. Whatever you want to share with it about your history, your values, your goals. And it'll be like a companion that not only can help you do the dirty work, like dealing with insurance companies and stuff like that, but also help you think things through and make better decisions in life. That to avoid some of the mistakes we tend to make because we don't think clearly enough about things. And, if we can bounce something off, should I get into this business relationship or should I get out of this?
Somebody who calls stop when we want to push that button and say, think about it. Yeah,
exactly. Yeah. To have this like little angel on your shoulder, to help you make better decisions. I think it'll be very profound and really foster human flourishing.
That lets me think about, I have to watch the second Blade Runner movie again, where he has this projection of his personal assistant. Also, there's a woman that interacts with him, and so really, this is that would help so much. The what helps more? This is 3 cases you had, and they are all really interesting. All bringing humanity in a new age. Like you said, it's more than electricity or internet or so. But there was out some papers of the Dario Amodei or Sam Altman, how we are like really near to those breakthroughs. how far is this? What is this horizon of this scenario?
Right. So again, going back to the idea of large language models can't get us there. So people like Sam Altman, of course, have to give the impression that they can get to AGI, but at the same time saying large language models aren't going to get us. We need some breakthroughs. They don't actually. They're fundamentally on the wrong path. If you're trying to get to AGI, and that's north, if you are going east, it doesn't matter how much money you throw at or how fast you go east, you're not going to get to north. And so I don't see how these companies are going to get to AGI. And they make vague statements now, we need a few more breakthroughs and we'll probably have it in maybe 5 or 10 years. But when people say 10 years, it usually means they don't have any idea. When I was a child, people said we will have a cure for cancer in 10 years.
Atomic power cars,
yeah, and flying cars.
Flying, but talking about that,
yeah. So they don't really have a roadmap because you cannot get with large language models. There is no path. You really have to throw out the architecture and start from scratch. Now, with the work that we're doing in cognitive AI, we currently we had quite a successful commercial business based on our core technology, but it had a lot of human crafted rules and business rules and knowledge that we put in manually into the system to do a good job, for the commercial applications. For example, this last Valentine's Day, we actually replaced 3,000 call center agents, where normally the company would have to hire 3,000 agents just for 3 days before Valentine's Day and 3 days after, which is a nightmare to train these people and so on. With our technology, we could totally automate that. But it took a lot of human engineering. Our system isn't yet smart enough to train itself. So we actually put our commercial business completely on hold because it was a distraction to us. All the energy that goes into finding new customers and improving the system. So we actually decided 5 months ago, to completely focus on getting our AGI technology. And we're currently training the system sort of at roughly a 3-year-old child.
Wow.
Now, a 3-year-old child clearly isn't going to have any commercial value. But, from a 3-year-old, we then use that as a stepping stone to get to 4 or 5, 6, and to 10. And by the time you get to, a smart, motivated 12-year-old, you're actually pretty close to being able to put them into a call center and give customer service. So we're working our way up now, starting from the ground up. I believe with our approach, we can actually get to like 10-year-old to 12-year-old within 2 years. And after that, it'll be maybe another year before we get to college graduate, because by that time, the system can learn very much by itself. So I believe we could be as little as 3 years away from having AGI, provided that you have enough people working with the right theory, with the right approach. With the wrong approach, it doesn't matter how many thousands of people or tens of thousands or hundreds of thousands work on it. But so people are realizing that large language models are not the right path, but there is not a good understanding of what the right path is, because the people in charge right now, their training is with big data. That's the only thing they understand. They're sort of a monoculture. If you start talking about cognitive psychology and you start to talk about concept formation and consciousness and free will, or you talk about epistemology, they just, their eyes glaze over. That's not an area they really understand or can relate to. So it's AGI is really held back by the success, the tremendous success of large language models, of deep learning.
Yeah, makes totally sense. If you have something, if you have one toy and it's an investor, I mean, they want to make money, no? Also, this is like a thing. And if I would be in the position, I probably would do the same, but to go for in this route. And if you say, I mean, I have a 3-year-old daughter and I see the abstract concepts she can think through. And it's so surprising for me because it's my first one. And she's like, uh,
Mhm.
being able to connect dots. Well, you say something a day or 2 days ago, and 3 days later comes something, and she connects the dots. So she's already able to think abstractly. So I think 3-year-old is already interesting, not commercially, but I mean, yeah,
Right.
it's
Yeah.
mhm.
But you know, really the key thing is that an AGI system has to be able to learn language and thinking from the ground up, you know.
Yeah,
And that's basically the level we're at now with our development. But you know, we don't really have sufficient funding to accelerate our development. So that's kind of a lot of my energy is spent in trying to get additional funding that we can expand our team. We know the work that needs to be done. So we're not in a research phase anymore. We're really in a development phase, but we need more of, you know, the right kind of people to build the curriculum, because that's a big part of it. That, you know,
yeah.
how do we teach the system effectively by giving it the right examples and you know, that it can build up this knowledge of language.
This is, I can imagine, really hard because if you have those successful models from ChatGPT and co, and they are actually having the money, it's hard to get the people. Yeah, makes sense because
Right,
this is all
right,
the
right,
shiny new thing. Yeah. Mm.
right. So, you know, it's just what we are seeing is just more and more influential people are actually saying large language models are not the way, and they are starting to look at other approaches. So, you know, that's really what's needed to
Mm.
get to AGI.
Wow. I can't. I mean, I have to do this question, and this is like I prepared you for it. It's a Terminator or Matrix question because if you have at a certain point, you say 2 years until 12 years, then it's really quickly until college graduate. Is this a risk for humanity?
Yeah, I don't believe so. In fact, I'd like to turn that around and say we probably need AGI to save us from ourselves. I mean, if you look at the zoo of the American elections now, for example, I mean, are those the two most competent people competing for this position in America? Or you look at, you know, the mess that Europe is in with, you know, I mean, you can pick your own examples. I'm sure people can identify some things that are not going well.
Mhm.
And so I think we need more intelligence to help us manage our affairs. But let me address the risk part of it. So there are a couple of distortions here. The one major distortion is, of course, Hollywood. You know, it's always the AI is always the bad guy that's going to try and kill everybody and take over the world. You know, so we have that kind of bias towards AI from the Hollywood perspective. So to get rid of that is not that easy. You know, people think about it. But probably the deeper thing is that there's been an enormous amount of money that has gone into what's called AI doomer community. That there are actually probably now 24 organizations, non-profit organizations, that have had collectively funding of more than $1 billion. That's a lot of money,
Mm.
$1 billion for researchers. And basically they're saying AI is going to kill us unless you give us money, you know, to figure out how we can make it safe, or how we can make it safe, basically. And that's the only community in the AI, in this conversation, that has actually had money. People who say that, no, it's not likely to cause a problem, don't have any of those nonprofits, don't have a voice. You know, like myself and other people working on it, I can't afford to spend my life you know, talking about why it's not going to kill us. And the AI doomers have certain fundamental misconceptions that they have, and there's some bad logic behind their thinking as well, which I could unpack, and I have on occasion done that, where their thinking goes wrong. But also fundamentally, hardly any of them actually work on AGI. You know, they have these academic ivory tower castles in the air of assumptions that they make that are not grounded in reality and how we really build systems. They kind of think, well, if a human gets so much power, then a human will abuse it. You know, that's kind of the analogy, and therefore an AI, if it gets a lot of power, it will somehow abuse it, and will just want to take over the world. But it actually doesn't follow, because the psychology of an AI is very, very different from the psychology of a human. What drives us, first and foremost, is our reptile brain. You know, our more primitive instincts, basically for survival and reproduction. I mean, that's what drives humans. It has to, otherwise we wouldn't be here. You know, survival, reproduction. An AGI isn't going to have those fundamental drives. It doesn't need them. Why would you want to build them in? Its drives will be to help you solve problems, to give you answers, and to solve problems. That will be its drives. It's not going to have this ego. It's not going to, So fundamentally, I think there's a misunderstanding on the psychology of AIs. And as I say, these organizations, fortunately, just have a lot of money and can be very persuasive. But I think they're wrong.
Interesting. Yeah, because actually, if you want to get money from someone in the Duma scenario, makes more sense than, everything is great.
Of course, if they say AI is going to be fine, give me money to spread the word, well, okay, just build it.
It's really like a flaw in the system. No? We click on the bad things. We read the bad things. News are the bad things. Newspaper with only good.
Right.
So
absolutely, exactly.
So that's interesting. And also, what I found interesting is this thing that if we have this lizard brain, it developed. It's there. We wouldn't develop that for an AI. Why? There's no reason.
Right. Yeah, that makes no sense. Because the actual AIs that are being built are built to do work for us. That's their purpose. That's, and if they don't do it, that's bad engineering. Then they're not doing their job. If an AI suddenly wants to go off and do its own thing, well, that's not going to be useful.
No, but even if it does, it probably doesn't have this negative, this territorial thought that we have.
Right.
Huh? It's like, and it does some research, does maybe some vacation in the sense of whatever vacation for the AI is, but it's like, okay. Yeah, great. Oh, Peter, there was a lot that was deep. And before I forget it, where can we actually find you? Where can we find Aigo? And
very easy. You can find me on LinkedIn, on Twitter. My email is peter@aigo.ai, and our website, obviously, aigo.ai, aigo.ai.
I will put everything in the show notes, and if you want to follow Peter on those thoughts, and they really they brought me a level higher here, because I mean, talking to the guy that coined AGI as a term, that's really I'm honored, actually. Thank you for that. And I would say, let's see what the next years bring. I might have you back on the podcast if it works out next year. And thank you for being here.
All right. Well, the pleasure. All right. Very good.
Thank you.
All right.
I really learned a lot. And what really was motivating me to do more AI is that AI is different from humans. We humans developed from animals, and we have those animal feelings in us and animal motivations. And I think AI will be the better humans at a certain point, but maybe not better, but different. And actually, that's the biggest takeaway from Peter Voss's interview. But yeah, the biggest takeaway, I mean, in general, AGI will arrive soon there, whatever the time frame is, wherever the money goes, but it's not far. Think about what it means for you, for your life. Artificial general intelligence is not so far away. We will have machines that think. That is definitely the future. Thank you for listening to the podcast, and I'll hope to have you back in the next episode. Signing off, Dietmar from Aigo.Berlin.